All right, welcome. Today we are going on a really cool journey. We're going to go from being someone who just reports on data to someone who is a true architect of data models. We are going to take those static, kind of boring spreadsheets and turn them into these dynamic engines that actually help you make big decisions. So let's get started and bring that dead data to life. You know, this quote just hits the nail on the head, doesn't it? You're staring at this massive spreadsheet, maybe 10,000 rows deep, and it's just silent. It's a dead collection of facts. Our job as architects isn't just to read what happened. It's to give that data a voice, to make it tell us what's really going on so we can shape what happens next. And that brings us to the real problem we're here to solve today, what I call the so what gap. It's that huge chasm between just reporting the numbers, saying what happened, and actually understanding why it happened. Because only when you know the why can you build a real strategy for what to do next. Our whole mission today is about building a bridge across that gap. So here's our game plan. We'll start with what it means to be an architect. Then we'll get our hands dirty taming that raw data. After that, we'll get into some really interesting stuff, engineering financial instruments, then building some cool interactive dashboards. The most important part, we'll apply something called the Sieve of Truth to our models. And we'll wrap it all up with a master blueprint you can take with you. You know, this first part is really all about a shift in your mindset. It's about evolving from being a reporter who just describes the past to an architect who actually designs systems to test out the future. It's the difference between asking what happened and asking what can we make happen. You're really moving from just consuming data to becoming a data strategist. So where do we even start? Well, it all begins with building a solid foundation. Our very first step is to take that giant, messy, dead collection of data and tame it. Turn it from chaos into something structured and ready to go. Okay, so our starting point is something called descriptive analytics. Just think of this as establishing the ground truth. It's a really clear picture of what's already happened. But, and this is a huge but, you have to understand its limitation right from the start. Descriptive analytics can show you that two things move together, a correlation, but it can never tell you the why. It can't prove causality. It's our starting line for sure, but it's not the finish line. Now, the absolute workhorse for taming data is the pivot table. This is the tool that lets you turn thousands of rows into a clean summary without writing a single formula. You've got your 4 key areas, filters, columns, rows, and values that let you slice and dice everything. But listen, there are 2 golden rules you've got to remember. 1, always include your headers. And 2, and this gets people all the time, pivot tables are not live. If your original data changes, you must hit that refresh button to see the update. Now, beyond just summarizing, our models need to reflect how things grow in the real world, right? That's where functions like ln and exp come into play. ln, the natural logarithm, is awesome for figuring out the time it takes for something to grow. Think of it as answering, how long did it take for that tree to get this tall? Or how long until that post went viral? Its partner, exp, does the opposite. It models the outcome of that growth over time. Just a little technical tip. You can't take the log of a negative number, so ln only works with positive inputs. exp is a bit more flexible. Okay, so we've got some basic tools under our belt. Now let's use them to build something way more complex. We're going to step into the world of finance, where these ideas are used to put a price on risk and opportunity. All right, let's slow down for this because this concept is everything. When we talk about financial options, you have to understand the premium. It is not the price of the stock. It's the price you pay for a right, the right to buy or sell something later, but with absolutely no obligation to do so. It's like an entry fee. And it makes perfect sense, right? The better the deal you're getting, like the right to buy a stock for way less than it's worth, the more you're going to have to pay for that right up front. That's the premium. And these rights come in 2 main flavors. First, you've got a call option. That's the right to buy. You make money if the price you locked in is lower than the actual market price later. The example here says it all. You get the right to buy for $50 what everyone else is paying $100 for. Sweet deal. A put option is the total opposite. It's the right to sell. In this case, you want your locked-in price to be higher than the market price. You get to sell your stock for $100, even if the market tanks and it's only worth $50. So how do you calculate the fair price, the premium for one of these options? Well, the famous Black-Scholes model does it with just 5 key ingredients. That's it. The current share price, the exercise price we just talked about, the risk-free interest rate, how volatile the stock is, and how much time is left. These 5 things are all you need to figure out the price of that right. Pretty amazing. Okay, so we've tamed our data, we've even modeled a complex financial instrument. Now, let's bring it to life. How do we go from a static spreadsheet that only we understand to an interactive tool that anyone can use to make decisions?
The goal here is to build what I like to call a strategic sandbox. We want to give people the power to play around and ask, what if? What if volatility goes up? What if we have more time? By using form controls, we can let them pull levers and turn dials to test these things themselves in real time without ever having to see the complex formulas running in the background.
Now here's a little pro tip. This is a technical thing that trips up a lot of people, but it's super easy once you see it. An Excel scroll bar can only spit out whole numbers, 1, 2, 3, and so on. But our models need decimals, right? Like for interest rates. So we use the helper cell trick. You link the scroll bar to one cell, the helper, and it will show integers. Then in the cell your model actually reads, you just divide that helper cell by 100. Boom! Just like that, your scroll bar is controlling a decimal and everything looks smooth and professional.
Okay, everybody, listen up. This next section is, without a doubt, the most important concept we are going to cover today. We've built our model, but how do we know if it's any good? How do we know if it's telling the truth? This is where we learn to filter out the noise. This is the Sieve of Truth.
So let's really take our time here, because this is critical. When we build predictive models, we often look at a metric called R-square. But here's the secret. R-square can be a lie. It will almost always go up as you add more variables, even if those variables are complete junk, just random noise. This gives you a totally false sense of security. The real story, the truth, is in the adjusted R-square. This is the honest metric. It has a penalty built into it. It will only go up if a new variable genuinely makes the model better. If you add junk, the adjusted R-square will actually go down, punishing you for making your model worse.
Here's the best way to think about it. It's like cooking. You add spices, your variables, to a dish. A little oregano, some basil, it makes the dish better, right? But what if you just start throwing in random stuff for the sake of having more ingredients? A little cinnamon, some nutmeg, you're not improving the meal, you're ruining it. That is exactly what happens when you add noise to your model. R-square will tell you, hey, you have more ingredients. But adjusted R-square will tell you, yeah, and now the dish tastes awful.
Let me give you one more analogy to really make this stick. Think of your model like a suitcase for a trip. Every variable you add is an item you pack. The more you pack, the fuller your suitcase gets. That's your R-square going up. But if you're packing useless stuff, like a bowling ball for a hiking trip, you're just making the suitcase heavier and less efficient. Your goal isn't the fullest suitcase, it's the most effective one. Adjusted R-square tells you how effective it is. This whole mistake has a name. It's called overfitting, and it's the biggest trap in modeling.
And look, here it is in action with real numbers. We start with a model using YouTube and Facebook ads. Our adjusted R-square, the truth, is about 0.899. Pretty good. Now watch what happens when we add in newspaper spending. The R-square, the lie, creeps up a tiny bit. But look at the adjusted R-square. It drops. That's the alarm bell. Newspaper spending is noise. It's the cinnamon in our pasta sauce. We throw it out. But when we try adding roadshow spending instead, look at that. Both R-square and adjusted R-square go up. That tells us roadshow is a real signal. We keep it.
The tool in Excel that gives us all this great info is called LINEST. It gives you a whole bunch of stats, but a real architect knows to look beyond just the R-square. The F-statistic, for instance, tells you if the relationships in your model are legit or if they could have just happened by pure random chance. You use that with degrees of freedom to establish real professional confidence in your forecast.
Wow, we have covered a ton of ground, from taming data to building dashboards, and most importantly, making sure our models are honest. So let's wrap this all up into a master blueprint you can use going forward.
Here it is, your cheat sheet. These are the big takeaways. Descriptive analytics tells you what happened. Pivot tables are your best friend for summarizing. Just don't forget the headers and the refresh button. The Black-Scholes premium, it's just the price of a right, not an obligation. For those cool dashboards, remember the helper cell trick. LINEST is your secret weapon for forecasting. And the #1 rule, the one I really want you to remember, is this. Always, always trust adjusted R-square. It is your best defense against that overfitting trap.
So I'll leave you with a final thoughts, a challenge really. The goal is not to build the biggest, most complicated model. It's to build the smartest, most honest one. And sometimes making something more powerful means taking things away. By removing the noise, you make the signal that much louder. So now that you have the sieve of truth, what's the first variable you're going to remove from your model to make it stronger? Thanks for joining me.